Dear students, today we will be discussing two rearrangement reactions involving diazomethane CH2N2. First is the Wolff rearrangement and Arndt-Eisert reaction. So first, coming to Wolff rearrangement, it was discovered by the German chemist Ludwig Wolff in 1902, and it involves the conversion of an alpha diazoketone to a ketene intermediate by the loss of molecular nitrogen, followed by a 1,2 rearrangement involving silver oxide catalyst or under thermal or photochemical condition. The ketene intermediate are very important intermediate because they are generally very unstable and it is not easy to isolate them, almost unable to isolate the ketene intermediate, and they undergo ready nucleophilic attack by water to form carboxylic acid, by alcohol to form an ester derivative, or with amine to form an amide derivative. So, Wolff rearrangement is the first reaction. It involves the conversion of an alpha diazoketone to a ketene by loss of N2 molecule followed by 1,2 rearrangement catalyzed using Ag2O or heat or light. And this is a very important intermediate compound and it can be easily converted to other important organic compounds like carboxylic acid, ester and amide. Coming to the mechanism, the first step involves the elimination of a nitrogen molecule, and this elimination is simultaneously followed by the migration of the R group, R plus group to form the ketene intermediate. In the second step, the water attacks the ketene carbonyl as a nucleophile and we will get this intermediate. The next step involves a proton transfer. This proton gives its electron to this oxygen and this leaves as H plus and it comes and attached to O minus. We will get an unstable diol compound which eliminates a molecule of water followed by tautomerization will give the carboxylic acid derivative. So that is the Wolff rearrangement. Coming to Arndt-Eisert reaction. This reaction is named after two German chemists, Fritz Arndt and Bernd Eisert. And it involves the conversion of a carboxylic acid into another carboxylic acid with one carbon atom more. That means to its higher homologue. RCOH is converted to RCH2COOH. So, converted to the next higher homologue. Therefore, this reaction is also known as Arndt-Eisert homologation reaction. And the reaction proceeds via a diazoketone intermediate followed by a diazoketone is formed and then this diazoketone undergo Wolff rearrangement in the presence of water and silver oxide catalyst or as discussed earlier in the presence of heat or light to give the higher homologue. Coming to the mechanism, first step is the nucleophilic attack of diazomethane at the carbonyl carbon of the acid chloride obtained from the lower acid and we get a tetrahedral intermediate which undergoes an elimination of chloride ion to form a diazoketone. The diazoketone then involves the attraction of proton to form a carbanion. In the next step, the carbanion next step is followed by the migration, just as in the case of Wolff rearrangement, a migration of the R group followed by migration of the R group to form the ketene intermediate, and the ketene intermediate involves a nucleophilic attack of water followed by proton transfer to form the diol. The diol eliminates a molecule of water via tautomerization to form the higher homologue. So that was two rearrangement involving the reaction with the diazomethane. I hope it is clear. In case of any doubt, contact me. Thank you.